Okay, this is 8.1 Webwork Homework Help. The first question says to find the distance AB across the river right here. It tells us that BC right here is 300. And it says it's found that angle B is 97. And it says that angle C is 18 degrees. And it wants us to find side AB, which I'm going to call little c here. So we're going to use the law of sines for that. I'm going to find this other angle by taking 180 and subtracting these other two. So this is 65 degrees. Now I'm going to use the law of sines. So the sine of 65 over its opposite side, 300, is equal to the sine of 18 degrees over its opposite side, c. And I can cross multiply now and get angle C. So actually, let me just show you that work. C sine of 65 equals 300 sine of 18. Divide both sides by the sine of 65. And you get C 102.3. And I'm not sure if we need to round that further or keep that further in our calculator. Let me try to enter that in. And looks like it works fine just to the 10th. Okay, the next problem, number 2, says a surveyor determines that the angle of elevation to the top of the building from the point on the ground is 25.6. He then moves back 59.2 feet. So now we're going to move back. So here's the building. He's going to move back here this distance, 59.2 feet, and determines that the angle of elevation is now smaller, which is 17.7 degrees. And the question is, what is the height of the building here? So what I'm going to do is I'm going to try to find this side right here. Let me use a different color. I'll try to find this side. I'll call it X. Because if I find this side, then I can use this right triangle to find the height of the building. So I'm going to first use this triangle here to find X. So to do that, I'm going to do 180 minus 25.6, which is 154.4 degrees. And then I'll do 180 minus these two to find this angle up here as well. So this angle up here is 7.9. Then I'll use the law of sines on this triangle. So I'll do the sine of 7.9 over its opposite side, 59.2, is equal to the sine of 17.7 over its opposite side, x. So I'm going to cross multiply and solve for x now. I end up with x times the sine of 7.9 equals 59.2 times the sine of 17.7, and now I'll divide both sides by this. That gives me 130.95. Now, I'm going to leave that in my calculator, and now I'm going to use this triangle right here. So what I'm going to do next is the sine of 25.6 equals opposite over hypotenuse. Okay, multiply both sides by 130.95, and you get 56.58 feet. Okay, the next problem gives us this triangle, and it says in questions 1, 2, and 3, we're going to be given two sides of the triangle in an opposite angle. And this is the ambiguous case because it could give 0, 1, or 2 triangles. So in each case, determine the number of triangles possible with the given parts. So let's say we have 6.6 for A, for the first one. Let's say we have 12 for B, and angle A is 48. Okay, so for this one, we could potentially have 0 triangles, 1 or 2, because if I were to swing this side over, it could be that, you know, it lines up over here, and this is still 6.6, and this is still 12, and this is still 48. So we have to check that, and then also, you know, it could be that that it's exactly the height, in which case there'd be 1 triangle, so it could be 6.6 is exactly that length, or it could be that 6.6 isn't long enough to even connect here, in which case there's no triangles. So let's figure that out real quick. So in the notes, we're dealing with an acute angle here. So we're dealing with one of these 3 situations. Actually, one of these 4 situations. And it's not this one because A is not bigger than B. So we're looking at these 3 situations here. So let's find the height then of this triangle real quick. The height of this triangle is right here. And I can find it by doing the sine of 48 equals opposite over hypotenuse. Multiply both sides by 12. So the height is about 8.9. And then we can compare using our notes that 8.9 is not equal to 6. So it's not this case. The height is bigger than the leg. So since 8.8 is bigger than 6.6, then that means that there should be no triangle. Okay, so let's try the next one where this is now 21.6 degrees. Side B is 12, and they give us angle A now. I'm sorry, I didn't do this right. Side A is 21.6, and angle A is 41. So now we have this leg is longer than the other leg. That situation is in our notes as well. That's right here. When we have an acute triangle where this leg is longer than the other leg, and so there's only one triangle. Okay, and then the last situation, we have A is 9.4, and we have B is 11, and we have this angle right here is 44. So let me try to find the height again really quickly by doing the sine of 44 degrees equals opposite over hypotenuse, multiply both sides by 11, and the height is 7.64. So now we can compare again using H is 7.64 and A is 9.4 in the notes. So we're looking at this situation right here because H is smaller than both A and B, the height. So it turns out we can make two triangles. And you can kind of, if you were to draw this out, you start with the 44 degree angle here, and this is 11. This side's smaller, it's 9.4. And so you can see that you could set up two triangles. This one, or you could swing this side this way and make this triangle where this is 9.4. So you have this bigger triangle, and you also have this smaller triangle that you can make. So there is two for that one. Okay, the next problem is a little easier because it wants us to find the indicated side. This time we're given angle, side, angle. If you remember from geometry, angle, side, angle was a triangle congruence theorem, which means there's only one triangle that we can do. So we can do the sine of 35 over its opposite side, x, equals the sine of 85 over its opposite side. But that's not going to work because we don't have this opposite side right here. So let's use the sine of angle B instead. Let's find angle B by subtracting from 180, which is 60. So we'll use the sine of 60 over its opposite side, which we have is 3. So cross multiply 3 sine of 35 equals x sine of 60. Divide both sides by the sine of 60, and you get 1.987. Okay, the next problem tells us that C is 4, angle C is 100, angle B is 35. Find the measure of angle A in degrees, and then the lengths of sides A and B. So they gave us this time angle, angle, side, which was a triangle congruence theorem in geometry. Therefore, there's only one triangle. We can find this by doing 180 minus 100 minus 35. So angle A is 45 degrees. And then we can find A and B by using the law of sines. So we'll do the sine of 45 over its opposite side A equals the sine of 35. I'm sorry, I'll use the sine of 100 because I have that opposite side 4. Cross multiply and solve for A. You get about 2.872. Now try this again, only this time switch the angle you're using. So I'll still use C, but this time I'll do B. Sine of angle B is 35 over its opposite side B. Cross multiply and solve, 2.33. Okay, the next problem says we have two triangles for this. So I'm going to draw both of them. We have a 30 degree angle here for angle A. Side A is 7 here. And side B across from angle B is 10. So I could draw this triangle, or I could draw this triangle where I swing this side 7 over where this is 7. So I've got these two triangles here. I need to find this side C in both of them. So in the bigger one, C is here, and in the smaller one, C is here. All right, so let's focus on the bigger one first. I'm going to do the sine of 30 over 7 equals the sine of B over 10 using the law of sines. And I'll solve for angle B, so cross multiply and solve for B, and you get 45.58. So obviously that's this angle here then, because that's an acute angle. So then I can find angle C by taking 180 minus these two, which is 104.4 approximately. And now I'll do the law of sines again for angle C, which is the sine of 104.4 over C equals the sine of 30 over 7. Solve for C and you get 13.56, which is the bigger one. Now I'm going to find the smaller one. So what you need to recognize is that this angle and this angle are the same, which makes this angle then 180 minus the 45.58. And keep in mind, I'm keeping all these in my calculator. I'm not rounding anything. So this gives me 134.4, obtuse angle in my calculator, not rounded. And then I'm going to find the new side C now. So now my triangle looks like this, where this is 15.58. If I take 180